Hi everyone, my name is Abhinav Singh, and welcome to Daily Data Structures. Notice that I've changed the format from PowerPoints to just working on my tablet. The reason I made this change was since we're starting data structures, it's a lot more helpful to dynamically picture what exactly is going on, since the static math and algorithm analysis is over. So, today's topic is going to be our second data structure, called the singly linked list, or the SList for short. We're going to be talking about its anatomy, its various operations, and then we'll discuss the runtime of those operations and discuss ways to improve them. Towards the end, I'm also going to go over one extremely important and really popular interview question that utilizes linked lists. So, let's start out with the anatomy. What exactly is a singly linked list? Well, a singly linked list is just a collection of singly linked list nodes, or SList nodes, that are linked to each other in one particular direction. So now a better question is, what is an SList node? Well, an SList node is just an object that stores an item and also stores a reference to the next SList node. Notice that this is what we call the linkage when we talk about singly linked list. So let me show you. Let me draw out the anatomy for you. This is a singly linked list node, and I'm going to call that SLN. That doesn't mean solution. It stores an item, which is some object that you want to store, and then it has a pointer to the next singly linked list node. That also stores an item. We'll call it obj2. And the next pointer for that is pointing at nothing, because it's the end of the list. So this is one example of two singly linked list nodes, or SList nodes. So by now you're probably confused as to how this all comes together. Well, we represent this data structure via two classes, the SList node object and the SList object. The SList node stores the item and the next pointer in the form of a node. However, the SList, however, stores the pointer to the first SList node, called the head, and also maintains the number of SList nodes in the SList. Another important thing to note is that all of the operations you do with an SList are done via the SList object, not the SList node. The SList node just encapsulates the object and prevents you from tampering with them when you call those operations in the SList class. So now that we understand the anatomy of an SList, we can now start to talk about the various operations that it can do. And the first operation that we'll be talking about is called insert. Insert. There are various types of insert operations, as you can insert items into particular parts of the list. We're going to be talking about insert front first. So let's take the following SList. It stores an item. Let's say the items being stored are integers, like 1, 2, 3, or 4, or 5, etc. I stands for item, and N stands for next. Right here. And N, we're going to mark with an X because it's the end of the list. So this is an SList. However, it's missing two things. The first is what we talked about, which was the head pointer. The head is just some pointer that's pointing to the first element of the SList. And the second thing we're missing is the size field. We're going to call it size here. The SList maintains the size. And in this case, the size is 4, since we have 4 SList nodes. The size is the number of SList nodes in our SList. So to insert front, we want to insert an item that's specified in the parameter, and then move it to the front of the list, and then change the head. So what exactly does that look like? Well, the first thing you want to do is you want to first make the new SList node that you're going to be inserting into the list. So we'll call that new node. And it's going to store the item that you pass into it, into the method. And we'll call it item. And then it stores a next pointer, which is currently null at the moment because we just created it. So what you want to do is you want to take this you want to take this next pointer and have it pointing at the first object because you want to make this the first object of your list and this the second. And then you want to take head and get it to point at this, which is the first object of your list, which becomes the new head. And then we want to update size. So size goes from 4 to 5. So let's do that. What we do first is we take end and we get rid of that x, and we get it to point at the first we get it to point at the original head. Then we take the head and get it to point at our new first node of the list. So then notice that what this ends up looking like is the following. 3, 4, 5. And I'm just going to leave out the eyes for now, just so you understand. But I'm sure you understand what's going on. Okay, the eyes are just storing their values. I'll just call it I. Note it with I. Each SList node is storing some item. And that's closed at the end. This right here was your new node. And head is now pointing here. Okay? And then the next thing we do is we update size to 5. However, by now you're probably thinking, how exactly do we just change these pointers around? Well, in Java, you can just do something along the lines of new node dot next, which is the next field of the new node, SList node, is equal to head, which is pointing to an SList. And then we say head. Then we just say head is equal to new node. And that's it. That's insert friend. All we're doing is we're creating a new node, and then we're just rearranging pointers. So now we want to start talking about the other types of inserts. So the next insert we'll be talking about is insert end. We're inserting to the end of the SList. So let's take the following SList. It stores some numbers. 1, 2, sorry, that was incomprehensible. 3, and 4. Okay? And then the head is pointing at the first element, and the size is equal to 4. Right? So now what we want to do is we want to insert the SList node at this point. So the first thing we do, like last time, is we create the SList node. This is the new node. Stores an item that we pass into the method, which is the parameter, and then it has a next, which is pointing at nothing right now. And it'll actually continue to point at nothing. You'll see why in a moment. So the first thing we want to do is we want to insert it here. So naturally you're probably thinking, what if we just called this node's next operator, the next field, and say this node.next is equal to this? However, the question is, how exactly do you call this node? How do you reference it? So currently right now, this is the point of the head pointer. The head is currently pointing at the first node. All that's pointing to this is the node before that, which is this node. This node.next is equal to this. And then the one thing that's pointing to this node is this node. This node.next is equal to this. However, the only way to get to this node is we need to walk the head pointer down from here to here to here to here. And then we have to make head point to this. Then we say head.next is equal to this new node right here. This is called walking down a list. So the way you do this is you create some while loop, and while head.next is not equal to null, we just keep calling the operation head equals head dot next. And that's it. That's all you have to do. So all you have to do is you have to walk head down until finally head is not pointing here and head is pointing here. And then we say head.next is equal to new node. And so then this next pointer is now pointing here. Notice, however, we're not changing this next thing here because this next field is the end of the list. So it doesn't point at anything because it's the last element. So that's it for insert end. Really not super difficult, but you need to make sure that you're not messing up the pointers. The thing with SList is you're very prone to make a null pointer exception at any point. So you have to be very careful about how you iterate through the SList and walk down. So now we've talked about insert, we're going to quickly talk about remove. The logic is literally the same, however the way you manipulate the pointers is different because you're removing instead of inserting. So let's talk about remove front. You're currently removing the first item of the SList. So let's take the following SList. Two, and points at another box. 3. And it's closed here. Well, let's just say the size is 3. And we say head is pointing at the first element of the list. So now all you have to do is you just say head is equal to head.next. We're just getting rid of this first element here because we want to remove the front of the SList. So all that happens is we just move the pointer this way. Notice that nothing is really pointing at this, so during garbage collection, the Java virtual machine will just get rid of it. And all we have is this SList. And then we have to make sure we update the size field. This is extremely important because many people forget this, and I've forgotten it definitely a couple of times in my life. So just make sure you're updating the size counter every single time you do that. So the next remove method we have to worry about is called remove end. And remove end is literally the same logic as what we were discussing before. All you have to do and I'm just not going to list the items for brevity's sake. All you have to do is you walk head down the list until you reach the penultimate node. So you walk head down until it's pointing here. So you say head equals head.next. And the moment you hit the penultimate node, meaning when head.next.next is not equal to null, then you want to say head.next is just equal to null. And you're just making this x. And this goes away. Notice that nothing is really pointing at this node, so the Java virtual machine gets rid of it during garbage collection. And then we update size to go from 3 to 2. And that's it. That's how you do remove end. So now that we've understood that, the third and last operation, which is even simpler, is called find. All you do with find is you walk down the SList, and you just keep checking to see if what you're trying to find